Hi, Assalamualaikum and a very good morning. So now we are in chapter 4, chemical bonding. And now we are still in the subtopic of 4.2 molecular shape and polarity, part 3 of the video. So in this video, we're going to learn about the explanation regarding bond dipole as well as the dipole moment. Last but not least, we're going to deduce the polarity of the molecule based on the shapes according to Vesper theory and the resultant bond dipole. So if we have our dipole moment mu is equal to 0, then we're going to have a non-polar molecule. If we have our dipole moment is not equal to 0, then we have the polar molecule. So we're going to learn about this concept in this video, which is in part 3. So without any further ado, let us start. So bond polarity. So as what you can see here, we have the fluorine molecule. So fluorine and fluorine, fluorine molecule consists of fluorine atom and fluorine atom, and they have the similar electronegativity. So for example, if the electronegativity of fluorine is 4.0, and then the electronegativity of another fluorine atom going to be 4.0. So the strength of attracting electron is the same on between the right hand side and the left hand side of the fluorine atom. And as a result, they're going to have a non-polar bond because they share the electron cloud symmetrically, sama rata. Meanwhile, for the HF bond here, so we have the fluorine which have a stronger electronegativity, for example 4.0. Meanwhile, the hydrogen which is less electronegative, which has a value, for example 2.2. So the fluorine which has a higher electronegativity value will pull the electron density more strongly towards itself. And as a result, they're going to carry a slight negative charge on the fluorine side and a slight positive charge on the hydrogen side. So this symbol here refer to the delta, which means a partial positive charge or a partial negative charge. So as mentioned, the sharing of electron in covalent bond, for example, the hydrogen fluoride bond, is not always equal. So covalent bond with unequal electron sharing are known as the polar covalent bond or known as the polar bond. And the atom with a higher electronegativity will have a greater share of the electron because it can pull more electron density towards itself. And because of the unsymmetric ataupun tidak sama rata, tak sama size electron density, we can say that the molecule here, the bond here is polar, and overall they have a polar molecule for the HF molecule here. Okay, and now we're going to focus on the dipole moment. So just now we look into the polarity of the bond untuk satu ikatan. Sekarang we're going to look into the molecular polarity secara overallnya. So dipole moment can be calculated by using a formula of mu is equal to Q times R, where it is defined as the product of the magnitude of the charge, which is the positive charge and negative charge, as well as the distance that separate the center of the positive charge and the negative charge. And the unit for the dipole moment is dBs, or labeled as D here, where D will have a value of 3.36 times 10 to the power of negative 30 coulomb meter. However, in this chapter, we are not interested with the value. So they know there's not going to be any calculation regarding to this dipole moment, but we are interested with the value whether it is 0 or not 0. So if the value is not 0, we can say that it is polar. But if the mu or the dipole moment here will have a value of 0, then the molecule, okay, is non-polar. And the direction of the polarity of the polar bond can be represented by using a cross and arrow here, where the cross and arrow here will refers to the positively charged side, and meanwhile the arrow here will shows that it towards the negative end, yang mana ada electron rich region, and the positive sign here will refers to the electron poor region or a partially positive charge. Okay, so now how can we determine whether the molecule is polar or non-polar? So the step is similar as what we have learned so far. So in order to determine whether polar and non-polar, we need to be able to draw the molecular shape first. So we need to draw the Lewis structure, we need to calculate the formal charge, we need to identify the class of the compound, and then we need to use the VSEPR in order to predict the molecular shape. So this is important. Step number 1 until step number 4, you have learned that in the previous part of the video. So you need to be able to do this. And from here, you can use the electronegativity value in order to predict the bond dipole. Bond tu polar ke tak polar? Okay. And from that, you can further determine the dipole moment. So whether the bond dipole cancel out or combine to produce a resultant dipole moment. So if the dipole moment is not equal to 0, then it is polar. If the dipole moment is equal to 0, then it is non-polar. So the steps here is very, very important. Alright, so now let us look into few of the example in order to understand step 5, step 6, and step 7. So as mentioned, the polarity of the polyatomic molecule will depend on the overall dipole moment, mu, or the resultant dipole of the molecule. So when mu is equal to 0, then it is a non-polar molecule. If mu is not equal to 0, then it is a polar molecule. So this is the thing that you should know. So now let's say if we have a hydrochloric acid here or the HCl molecule. So you know that the chlorine has a higher electronegativity. So it will pull more electron density towards itself. So you know that the bond dipole will be created from hydrogen to chlorine, and as if the electron density will be more towards the chlorine. And you know that because when they have a unsymmetric dipole or unsymmetric electron distribution, then you know that the HCl gonna be the polar bond. And as what you can see here, the bond dipole will only go in one direction. So the bond dipole does not cancel out. Okay, kerana dia ada lebihan di sebelah kanan. For example, you have 10 Newton on the right hand side. Okay, and as a result, you know that your bond dipole, which is your mu, the dipole moment is not equal to 0 because as if you have 10 Newton on the right. And because when you have mu is not equal to 0, then you know that it is a polar molecule. Alright, now let us look into the hydrogen here. So hydrogen and hydrogen will have the similar electronegativity. Daya tarikan yang sama pasal atom yang sama. And because of that, there not gonna be any bond dipole. So what you can say that H and H here is a non-polar bond. Kita tengok bond dahulu. And then, because there is no bond dipole, pasal daya tarikan sama, so there's not going to be the bond dipole. So you know that your mu here supposed to equal to 0. Okay? And as a result, when we have a dipole moment equal to 0, then we have the H and H here to be the non-polar molecule. Okay? Now let us look into a more complex example. For example, our carbon dioxide here. Okay, so let's say if we have our carbon dioxide, so you know that the oxygen atom will have a higher electronegativity in comparison to carbon. Similarly, on the left hand side here. So because of this, the electron distribution will move towards the oxygen more because it is more electronegative. So it's going to be having a bond dipole on the right hand side towards oxygen, as well as on the left hand side to another oxygen on the left. Okay, and as I mentioned, we need to look into the bond first. So we know that the bond between carbon and oxygen are polar bond. Okay, dia adalah polar bond, tidak dinafikan. However, the two bond dipoles are equal in the magnitude. So you know that sebelah sini adalah 10 Newton. On the right hand side we have 10 Newton for example. And then on the left hand side we have another 10 Newton. So the 10 Newton on the right hand side and the 10 Newton on the left hand side can be cancelled out. Okay, so when they got cancelled out, we know that our mu, which is for our molecule overall, will be equal to 0. So as a result, our mu here is 0, and then the molecule gonna be a non-polar molecule. Okay, so be very careful. CO is a polar bond. Okay, walaupun dia polar bond, tetapi dia boleh cancel out because of its shape on the right hand side and the left hand side. And as a result, secara overallnya, dipole moment is equal to 0, and hence it is a non-polar molecule. Now let us look into another example, which is the BF₃ here. So similarly, the BF₃ will have different terminal atom. So fluorine is very electronegative here and here. And the boron gonna be the more electropositive atom. So the electron density will be unsymmetrical, where there's more electron density on the fluorine side. So they're gonna be a bond dipole created from boron to fluorine. So one up here, one here, and then another one here. So similar as what I've shown here. So what you can say is that the BF bond is a polar bond. Kita tengok bond dahulu. However, BF here, and BF here, it is arranged symmetrically, and hence you can say that the dipole can cancel out. Macam mana dia boleh cancel out? Because when you have on this direction and then you have on this direction, you're gonna create a resultant forces in the center here. So the resultant on the front and on the upside and the downside gonna be cancelled out, and as a result, your mu will be equal to 0. Okay, here, and then they're gonna produce in the below here, right? So up and down gonna be cancelled out, and as a result, mu is equal to 0, and hence it is a non-polar molecule. Okay. Now we're gonna look into the example 1. So we have to draw their shape, which is according to VSEPR, and then we need to state whether this molecule are polar or non-polar. So this example here, we have covered that in the previous video, which is in the subtopic of 4.2 part 1. So we have our ammonia and as well as our water. And it is important that we have drawn it according to its correct shape, which is according to VSEPR. Okay, so once we have settled with step number 1, 2, 3, 4, and now we need to go with step 5, 6, and 7, which is we need to determine whether the bond is polar or not polar. So nitrogen and hydrogen. So you know that the nitrogen gonna be more polar, okay, and the hydrogen is more electronegative, and here is more electropositive. Okay, and as a result, they're gonna be a bond dipole towards nitrogen. Okay, so NH here is a polar bond, and as what you can see here, so the bond dipole cannot cancel out, okay, because they're gonna produce a resultant on the front side. Go that direction, and then go another direction, so the bond dipole will not be cancelled out, and as a result, the mu here is not equal to 0. So since it is not equal to 0, then we have a polar molecule. Okay, and now let us do for the water molecule here. So similarly, we have oxygen, which is a more electronegative atom, and then we have hydrogen, which is more electropositive. Okay, so a bond dipole gonna be created between hydrogen and oxygen bond. So the arrow here towards the more electronegative atom. Okay, similarly to here. So what we can say is that we have OH polar bond. Okay, however, the bond dipole is not cannot be cancelled out. Okay, okay. Pasal satu sebelah sana, if I were to expand the arrow, it's gonna be on that side, and then here gonna be on the other side, and hence it's gonna create a resultant at the middle. So when they have a resultant and there's no force they're gonna cancel out, then I know that my mu here is not equal to 0. And as a result, I'm gonna have a polar molecule. And that is the reason why water is a polar molecule, because the dipole moment here is not equal to 0. And as what you can see, the shape is very, very important. If you draw the shape incorrectly, okay, kalau kamu lukis shape tu secara tidak betul, for example like this, kamu akan dapat jawapan yang berbeza. Because when you draw the dipole moment to be like this and the dipole moment to be like this, what you can see is that the bond dipole will be cancelled out. 10 Newton sebelah kanan, 10 Newton sebelah kiri. And as a result, your dipole moment gonna be 0. And you may expect it to be non-polar. Okay, so this way is wrong. And this is very important because when you got your shape wrongly, your determination will also be wrong. So you need to ensure that your step number 4, which is to get the correct shape according to Vesper, is correct. Then only you can determine whether it is polar or non-polar. Alright, so I hope that you can see the clear picture here. Now we're going to move on to the next example, which is the ClF₃ as well as the I3-. So for the ClF₃, we're going to have a shape of T shape here. And from here, you also need to determine the polarity of the bond first. So fluorine is electronegative, fluorine is electronegative, fluorine is electronegative. And chlorine is more electropositive in comparison to fluorine. So we're going to have a bond dipole created between Cl and F, similar to here towards fluorine, and then here towards fluorine. Okay, so what you know that the ClF bond is polar. Okay, however, the bond dipole cannot be cancelled out. Okay, so the above and below here can be cancelled out. Okay, let's say 10 Newton and 10 Newton, so they're going to be cancelled out. However, you have the resultant on the right hand side. So overall, the mu here is not equal to 0. And as a result, the ClF₃ is a polar molecule. Alright. Now, how about this one? I3-. So I, and I, dia datang daripada atom yang sama. So they came from the same atom. So when they came from the same atom, the electronegativity is the same. So when the electronegativity is the same, so you know that the I and I is a non-polar bond. Okay, pasal dia tak ada, dia punya distribution is the same. Electron distribution is the same. So basically, they are non-polar bond. And as a result, the mu here is equal to 0, and hence they are a non-polar molecule. Dia langsung tiada bond dipole, and then as a result mu is equal to 0, and hence it is a non-polar molecule. Alright. Now we're going to do the last example, which is example 3. So we need to draw the shape and state whether these molecules are polar or non-polar. So this example here, you need to draw from the drawing of the Lewis structure, get to the correct shape, and then you need to determine whether the molecules is polar or not. So for sulfur here, SF₄, sulfur will have 6 electrons, so 6 times 1. And then fluorine, you have 7 times 4. So it's going to be 6 electron here, and then you have 28 electron here. So 6 plus 28 going to be 34 electron. So from here, you know that between sulfur and fluorine, sulfur is the more electropositive. So sulfur going to be the center atom, and then it is bonded with 1, 2, 3, and 4. Okay, 4 fluorine. So we have used up 2, 4, 6, 8. Kita dah gunakan 8 electron. So the balance of electrons that we have going to be 26 electron. So the 26 electron will be used in order to octet the terminal atom. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have used up 24 electron. So we have balanced 2 electron. So the 2 electron here will be placed for the central atom 1 and 2. And now we need to determine the class. So the class of the central atom going to be A for representing the central atom. And then bonding pair going to be 1, 2, 3, 4, AB4. And then we have 1 lone pair. So it's going to be AB4E. Okay, so when we have the class of the molecule to be AB4E, then we know that it is a seesaw shape. Okay, dia mempunyai shape seperti jongkang jongkit. So we need to draw it correctly according to Vesper. So you can draw it to be something like this. Okay, so you can draw it to be something like this, or you can also draw it to be something like this. So masih maksud yang sama. So dua-dua shape adalah diterima. So when you having the correct shape according to Vesper, then only you determine whether the molecule is polar or not. So we're going to start with the bond. So fluorine and sulfur. Fluorine is very electronegative. And sulfur is electropositive. So they're going to be a bond dipole in between sulfur and fluorine. And similarly to here, and then similarly to here, and then similarly to here. So the above and below one can be cancelled out. Okay, so what you can say first is SF bond is a polar bond. And dipole, the bond dipole cannot be cancelled out. Okay, kenapa tak boleh cancel out? Atas dan bawah boleh, tetapi di sebelah sini they're going to create a resultant bond dipole. So you know that your mu is not equal to 0. Okay, and as a result, they're going to be a polar molecule. Alright, and it is as mentioned again, it is important that you draw it to the correct shape. Sebab kalau shape kamu salah, you will expect you may get a different answer. So you may say that here and here can be cancelled out, and here can be cancelled out, dan seolah-olah kamu akan dapat mu is equal to 0, and hence it is non-polar molecule. So this way is the wrong way, because when you got the incorrect shape, your determination of polarity will also be wrong. So be very careful. You need to draw the correct shape first. Okay, so now let us look into the example of XeF₄. So the valence electron of Xe, which is xenon, going to be 8. And then we have 4 fluorine, so it's going to be 7 times 4. Okay, so we have 8 here, and then we have 28 here. So 8 plus 28 going to be 36 electron. So xenon and fluorine, so xenon going to be the central atom. So Xe, and then we're going to have 4 bonding pairs to join the fluorine. Okay, so we have used up 8 electron. We're going to left with 28 electron. So the 28 electron will be used in order to complete the octet at the terminal atom. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have used up 24 electron, and then we have balanced 4 electron. The 4 electron here will be used in order to place at the central atom. 1 and 2 here, and then 1 and 2 here. And when we got the structure to be like this, and then we know that the class is going to be A, representing the central atom, and then we have 1, 2, 3, 4 bonding pair. So it's going to be AB4, and then we have 2 lone pair. So it's going to be AB4E2. So when we have the structure of AB4E2, then we know that we're going to get the shape of the square planar. Okay, so we're going to get the structure to be something like this. So secara kebetulan, what I draw is the same as the Vesper. Okay, and as what you know that the fluorine is more electronegative in comparison to xenon. Okay, so the bond dipole going to be created from the xenon to fluorine. So they're going to be a bond dipole here, a bond dipole here, the bond dipole here, and then the bond dipole here. So you know that the XeF bond is polar. Okay, even though they are polar, but the bond dipole is a polar bond, and then the bond dipole can be cancelled out. Dia boleh di cancel out. Kenapa? Because when we have on this angle here, and then we have another bond dipole on this angle here, it's going to create a bond dipole on the right hand side. Similarly, on the left hand side, we can create it on this way. So let's say if you have 20 Newton here, and then you have 20 Newton here, this force and this force can be cancelled out, and hence you can say that your mu is equal to 0. So when mu is equal to 0, then you have a non-polar molecule. Okay, so this is how you answer the question of the molecular shape and polarity step by step. Okay, so I think that's all for today's video. See you again some other time. Bye.